Problem 2. In trapezoid ABCD, AD to BE is 4 to 3, BE to EC is 2 to 3. The area of triangle BOE is 10 less than the area of triangle AOD. So we're being asked, what is the total area of the trapezoid ABCD? A lot of the models we've seen so far has something to do with triangles. It either includes triangles or is a triangle. And here we see 3 triangles and a quadrilateral. So our first thing is to try to apply the butterfly model or the Dovetail Theorem to it. So the best way to do this is to connect DE. Now we have a triangle DEC and the butterfly model on the left side. And let's first use the first ratio, 4 to 3. So this would be 4, and this would be 3. And we'll look at the other ratio later. So this, in this case, this is A and this is B. Remember how in the lesson we talked about how we can count units like this? And here A is equal to 4. So this top section we can think of as 4 squared units, or 16 units. Down here is 3 squared units, or 9 units. And both AOB and DOE can be the number of units that is A times B. So they're both 12 units in this case. And remember, we know that the area of triangle BOE is 10 less than the area of triangle AOB. And we know that, so 10 is their difference in area, but their difference in units is 7 units. So how much would 1 unit be? 1 unit would be equal to 10/7. So since we have the correspondence between a 1 unit and the area that it represents, the only thing we're missing now is how many units is DEC. Well, DEC, let's first look at triangle BED then. Well, triangle BED is the combination of 12 units and 9 units, which is 21 units. And now this is when our second ratio comes in. BE to EC is 2 to 3. So if here this is 21, here this would be 31.5. So DEC is 31.5 units. Now our final step is to add everything up and times that by 10/7. So we have 80.5 after you add up all the units, times by 10 over 7, and we get 115. So our final answer is 115.